Welcome to OSDU Data Platform Application Developer Training, Ingestion Workflow module. In this presentation, I'm going to talk about the ingestion workflow. In general, how data is loaded or ingested into OSDU Data Platform. I will give you an overview of the data loading process, then cover the manifest-based ingestion approach, introduce you to DAG development, and finally, provide an example of the process to ingest an LAS file into OSDU Data Platform. I will start with the data loading process overview. This slide shows a high-level schematic data flow from existing data source into an OSDU Data Platform instance. Data passes through the ingestion workflow and services and remains at the data lake until indexed and then available to the users or processors for consumption. On the bottom of the diagram, the main phases of data loading process are depicted: data preparation, data ingestion, indexing, and consumption. Each of these phases will be further explained. Let's begin with data preparation phase. Existing data, data sources, and data providers are not always fully compatible with the data schemas in the OSDU data platform, nor are these sources compatible with the modern data platform setup that consists of the data lake and the well-defined metadata layer. Therefore, some preparation has to be done to make data from these sources available in the OSDU data platform and to identify which data can be uploaded to the cloud due to law regulations or other constraints. At the end of this preparation phase, you should have data and its metadata prepared to be ingested into OSDU data platform. Let's continue now with data ingestion phase. Generally speaking, there are two types of data ingestion into the OSDU data platform. Data or files ingestion. Examples of this kind of ingestion are LAS with XML, CSV, and other file types. And metadata ingestion. This kind refers to the ingestion of metadata JSON documents which are formed using the defined OSDU data platform schemas. Files are ingested into object storage in either four possible ways: using cloud-specific tools which work with files and file collections, using the file service which work with files, using dataset service which work with file collections as well. In any of these three ways, data is finally ingested into the permanent area and in some cases passing through the staging area. For a detailed description of these options, please check presentation on file and dataset service and consult your cloud provider for specific tools. Finally, the fourth option is data domain management service utilities, which currently work with the seismic file storage using a specialized store option. To learn more about seismic store options, watch the seismic DMS presentation. Metadata is usually ingested using a workflow approach. This slide shows the current metadata ingestion approaches. The first approach is extract, transform, and load. In ETL, data is exported from the source system, then transformed to an OSDU data platform schema, and finally loaded into the platform. This approach requires tools to transform data from the source format to a schema, and a data manager that is responsible for maintaining consistency and completeness of data. Examples of this approach are manifest-based workflow and with XML workflow. The second approach is extract, load, and transform. In ELT, data is extracted from the source system and loaded as is, then transformed to an OSDU data platform schema. This approach requires a registered workflow that can handle the specific incoming format. Examples of this approach is CSV workflow. The third one is external data source. In this scenario, data is not really ingested. Instead, the curated metadata is created to make the data discoverable in the external system. This diagram depicts the ingestion workflow in the OSDU data platform. A workflow is a sequence of tasks that process a set of data. A workflow is represented as a directed acyclic graph, or DAG, where every node is a task. As already mentioned, a workflow can be either ETL or ELT, depending on the way it ingests and transforms data. The ingestion workflow process can start with the ingestion service or with a workflow service. The goal of the ingestion service is to hold the business logic for the specific workflows, and the goal of workflow service is to wrap the workflows instance for loosely coupling with underlying technologies, in this case Apache Airflow, which the platform is currently using to build, execute, and monitor workflows. Ingestion Workflow uses OSDU Data Platform service to perform validations and to store data in the OSDU Data Platform. I will review those operations in detail. Let's switch to the indexing phase. Indexing occurs on every storage observed, adding, updating, or deleting records. After the record is changed in the storage database, the message broker is triggered and the record passes to the Elasticsearch for indexing. Indexing is an asynchronous process which may take some time for making a record searchable via a search service, even if it's already available via the storage service. Here is an example on how indexing occurs. For every observed operation in the storage service, a message is sent to a records topic with the name of the operation, the ID of the record, and the kind. A cloud function is listening to the topic and triggers an API call to the indexer service for every message. Indexer fetches the record and schema record and creates the elastic record according to the mapping defined for the schema. If indexing fails, a retry task is enqueued. The index record is saved using the Elasticsearch API. Finally, let's review the consumption or delivery pattern. We can verify that the metadata was correctly ingested using the search service, which in turn delegates the query to the Elasticsearch. For more information on Search API and queries, please watch Search Service video recording. Now, let's describe the manifest-based ingestion. A manifest serves as an envelope of other group types such as master data, reference data, and data, which includes work product components, and datasets. The general process to ingest a manifest is to prepare the manifest as a first step. For that, it is necessary to preload data to the object store if there is a dataset within the manifest, and to populate the manifest with relevant business data. Then, the second step is to ingest the manifest by triggering an already registered workflow. In this slide, you can see the anatomy of a manifest. A manifest may contain master data entity types, reference data, or data as work product components, and datasets. Examples of specific entity types are shown to the right side of the group types. For further reference of specific entity types, see the data definition repository holding entity type schemas. The general implemented features of OSDU manifest-based ingestion DAGs are schema validation, which validate manifest against its definition schema. Referential integrity validation, which validates internal reference within the manifest and external reference already present in the OSDU data platform. Manifest analyzer, which enqueues entities in topological order, which allows process records with saving referential integrity, and saves valid data into storage service via storage service API. This slide shows the manifest-based ingestion workflow tasks. The template for tasks is known as an operator in the Airflow context. Every operator is responsible for a process or validation of the manifest data. For instance, here we can see the update status operator updates the workflow status using the workflow API. Validate schema performs schema validations via the schema service. Ensure in manifest integrity validates internal references in the manifest and external reference already present in the OSDU data platform via search service. Process manifest perform the final processing and store valid manifest data via the storage service. In this section, I will provide a brief introduction to DAG development. You may want to learn how to build, modify, and deploy a DAG. In this manner, you can extend the existing functionality of the workflows already implemented by the OSDU forum or adapt them to your business data flow needs by adding new operators, removing unnecessary ones, and changing their sequence. It is important to note that this quick guide employs Apache Airflow. You can see three main components of the manifest-based ingestion DAGs: its definition file, the definition of these operators, and the libraries used by the operators. In the DAG definition file, the DAG is declared as a collection of operators and the dependencies between them. Every operator is defined in a separate file by implementing the execution hooks. Finally, the manifest-based ingestion DAG delegates most of its core logic to the Python SDK. This slide shows the structure of the manifest-based ingestion repository that holds the DAG definition files as well as the operator definition files. It is best practice to install the libraries in the Airflow instance instead of copying the source code. As previously mentioned, for the manifest-based ingestion, most of the core logic is delegated to the Python SDK. Therefore, let us review the Python SDK structure. The Python SDK implements the main OSDU data platform REST API clients like storage, schema, search, legal, etc. The libs folder contains the core logic of authorization, configuration, validation, and processing. The providers folder holds specific cloud providers implementations. The model folder contains a simplified OSDU data platform model of commonly used entities for the clients to use. The setup of the production environment is typically responsibility of the DevOps or infrastructure team, but a developer should also ensure that there is an Airflow installation, that Python and main dependencies used in DAG are already installed. Once you have modified or enhanced the DAG, you may want to test your changes in the Airflow instance. For this, identify the location of the DAGs and operators directories in the Airflow installation and copy your source files to those locations. Now, let's review an end-to-end example of how to ingest an LAS file. In this example, we are building a manifest for an LAS log file. First, we need to upload the LAS file to the object storage. Note that the end goal of this step is to make the file record available in the permanent area. Then, we need to create a file generic and add it to the manifest as a dataset. Then, we need to build the well-log work product component and link the LAS file metadata record as a dataset. Then we build the work product and wrap all in the manifest data group type. Now we are ready to start the ingestion process by triggering the workflow. So we register the workflow if not already done, and then we trigger the ingestion process. Finally, we verify the ingested metadata records using the Search API. At the first step, the end goal is to make sure we upload our file to the object storage permanent area. The solid line depicts the flow we are going to follow in our demonstration later. We use cloud-specific tools to move in bulk data files from on-premise or from other cloud locations directly to the permanent area. Consult your cloud provider's documentation for more details. Alternatively, the dotted line shows the flow using the file or dataset service to upload files, first to staging, then to permanent area. The next step is to create the LAS dataset record. In our example, we use file generic as the metadata entity type. There are two considerations. First, the file source information should be correctly populated so that the LAS file can be correctly retrieved later. And the second one is that the file generic should be placed as a dataset of the manifest we are going to build. The third step consists in creating the LAS metadata record. For this, the well-log entity type is the right choice. It is possible that you need to build a parser to extract relevant information from the LAS file to populate the well-log metadata record. Some utility scripts are available in the community Open Test Data repository. And make sure you refer the recently created LAS dataset with a surrogate ID. Then, create the work product metadata record that would hold the reference to the recently created well-log work product component. Wrap everything with the data group type of the manifest. In the next step, we are triggering the workflow via the workflow service. The Workflow API also provides an endpoint to trigger an already registered workflow. The endpoint expects a POST request with a route containing the workflow name and a body with the following structure: the payload field with app key, which is an unused legacy field, a partition ID field, and a manifest field that could be a single manifest or an array of manifests. Also, it is important to note that we are ingesting a well log, which refers to a well bore, and that in turn it refers to a well and contains other references to organizations, unit of measures, among others. All these entities should be already ingested into the OSDU data platform, so our data passes through the referential integrity validation and remains consistent within the platform. After our data is ingested, we can verify if it was correctly stored and indexed by issuing a query to obtain recently created metadata records. This ID can be obtained from the Airflow logs or more easily from the Airflow XCOM storage, which report the IDs of the successfully stored entities. Now, let's register a DAG. For this, we need to give a name to our workflow. I have chosen OSDU_ingest. Let's retrieve the list of all of the workflows that we have. With our source file in place and our workflow registered, we are ready to start ingesting the manifest. Note that the dataset includes surrogate key ID, and we have our manifest updated with the file source path value of our LAS file in object storage. We can check if our workflow has finished by using the status workflow call. Now let's go to our Apache Airflow instance. If we navigate to our DAG and check the results of our process manifest operator, we can see the records ID created. Let's double check that our records are in fact ingested by using the Search API. If we want to get rid of this workflow, we can execute the delete workflow call. In this example, we have demonstrated how you can ingest an LAS file using the OSDU data platform Ingestion Workflow API.